Okay, so today we're given a curve with the equation x cubed plus xy plus y cubed plus 29 is equal to 0, and we're told p is the point 1 minus 3. For part A, we want to show that p lies on the curve. So this is quite a simple problem, but it occurs quite often, usually for a mark, maybe 2 marks if you're lucky. And all it's looking at is doing a substitution. Now, because our curve is made up of x and y terms there, we can substitute both our x value and our y value into the equation, show it's equal to 0, and if that's the case, then p must lie on the curve. Alternatively to this, if p did not lie on the curve, it would not be equal to 0, and that might be another alternative question there. So, x equals 1, and y is equal to minus 3. We've got 1 cubed plus 1 times minus 3 plus minus 3 cubed plus 29. Now it's important with these to make sure that you do enough working here. So you've got 1 minus 3 minus cubed is a minus 3 cubed is 27 plus 29, which is equal to 1 plus 29, 30 minus 30, which is equal to 0. And it's at this stage we can say therefore, and this is important to make a statement, p lies on the curve. They will be looking for that statement because really it's a bit of a proof there. So let's take this to the next level then and find the value of dy by dx at p. Well, we've got our point p. We want to find dy by dx, we're going to need to differentiate our curve, but as we already know, it's made up of a mixture of x and y terms there, so we're going to have to use the rules for implicit differentiation. And we've got an x times a y term there, times product. We also need to use the product rule as well. So let's go through our expression then. Well, we differentiate x cubed with respect to x, you get 3x squared. Well, we differentiate xy, well, we can leave the x times the differential of y, dy by dx, plus y times the differential of x, which is 1, so we can just leave that as y, plus the differential of y cubed, which is 3y squared times dy by dx. The differential of a constant, 29, is 0, and the differential of 0 there is still 0. So we have our expression. Now we could rearrange this if we just wanted an expression for dy by dx, but we don't want that, we want a value. So we can take our point p at 1 minus 3, and we can substitute in. When x is 1, y is minus 3, so we have 3 times 1 squared plus 1 times dy by dx, minus 3 plus 3 times minus 3 squared times dy by dx is equal to 29. 3 times 1 squared is 3 plus dy by dx, minus 3 minus 3 squared is 9 times 3 plus 27, dy by dx is equal to 0. 3 minus 3, 0, 1 dy by dx plus 27 dy by dx, so 28 dy by dx is equal to 0, and therefore finally we can say dy by dx is equal to 0. So that's our value of dy by dx at p. Part C says explain the significance of the point P. So that's when you need to remember something. If dy by dx is equal to 0, that's telling us something key. It's telling us that we have a stationary point. So therefore, point P is a stationary point. And then just clarify that as dy by dx is equal to 0. Okay, and that's how we solve and show that point P lies on the curve, the value of dy by dx of P, and explain the significance of P for the curve with equation x cubed plus xy plus y cubed plus 29 is equal to 0.